All right, this video is on solution stoichiometry and kind of a little more advanced solution stoichiometry. So this is in the advanced stoichiometry notes, and so we have really a part A and a part B here, even though it's not labeled that. So how many grams of aluminum are required to this much hydrochloric acid? So the first thing that we need is a reaction. So we have aluminum and hydrochloric acid. Then we are going to produce. Aluminum is going to replace the positive ion in the compound since this is a single replacement reaction. And we're going to end up with aluminum bonding to chlorine and hydrogen gas. Then we need to balance that. So for this one, I know I'm going to have to put a 2 here, which is going to make me put a 6 here, a 3 here, and a 2 here. Okay, so in part A, we're looking for how many grams of this. We have 35 milliliters of hydrochloric acid, and it is 2.0 molar. All right, so for this one, the first thing we want to do is find our moles. And so molarity times liters gives you moles. So anytime you have molarity in liters of something, you're going to multiply that together to get your moles. Now, this is milliliters, so we have to move the decimal 3 places to get liters. So 0.035 liters. And so if I take 2 molar and multiply it by 0.035 liters, I'm going to end up with 0.070 moles of your hydrochloric acid. And I just like to do that work all in one line underneath hydrochloric acid. So now I have my moles. Now I can go somewhere because I can use mole ratio at that point. So if I have 0.070 moles of HCl, and I'm going to react that with aluminum. So we can just use mole ratio, moles of hydrochloric acid to moles of aluminum. And then from our balanced equation, the coefficient here is 6 and the coefficient here is 2. Then we have moles of aluminum, but we want grams. So now we need to use molar mass. So in 1 mole of aluminum, we have 26.98 grams of aluminum. So everything on top multiplied together, divided by everything on the bottom multiplied together, 0.63 grams of aluminum, because I did need those 2 sig figs. All right, so that is the answer to part A. Now for part B. When we have these square brackets, and that's a very important notation when we are dealing with chemistry topics. Square brackets mean concentration in molarity. Okay, so it's going to be our moles per liter of whatever's written on the inside. And in this case, for this particular problem, we're looking for the concentration of our aluminum ions in solution. All right, so for this one, the information given in the problem has to deal with hydrochloric acid. So we're going to say that that is our limiting reactant, and that's what we would want to start with in our dimensional analysis. So if this is let's say, actually, for this particular problem, let's say we are using that 0.63 grams of aluminum, which means, and so it's a little unrealistic, which means that they're both going to run out at the same time. All right, so we're not going to have any excess reactant because that's going to make this a little simpler as we learn it, but later the problems will get a little more complex. So the aluminum ions, the source of those are going to be from our aluminum chloride. So that is what we want to go to next. So I'm going to start with my hydrochloric acid, moles of hydrochloric acid, and I'm going to go to aluminum chloride. So moles of HCl to moles of aluminum chloride. All right, and that is going to be 6 and 2. All right. Then I need to get this to just aluminum ions because molarity is moles per liter. So I know I can get my moles this way. And so the question is, in 1 mole of this, how many aluminum ions are there? Well, just to kind of take a step back, aluminum chloride is made up of aluminum ions and 3 chloride ions. So it is, for every one of these, I have one of these. But for every one of these, I have 3 of these. Okay, so we're just using the how many of the ions are actually in this formula unit. So 1 mole of aluminum chloride has 1 mole of 8L3 plus. So it just says for every one of these, I have 1 aluminum in there. So now I can calculate my moles of aluminum ions, 0.023 moles of aluminum ions. But that doesn't quite answer the question because molarity is moles divided by liters. So in this case, I need to divide by liters so I can get my molarity. And when we look back at the problem, we realize we've got solid aluminum, so that's not going to be any liters of solution. And we've got 35 milliliters of that hydrochloric acid. So that's all the solution that we have. So at the end of this reaction, that water just didn't disappear. It's going to be there. So we're going to have 35 milliliters of solution there. So aluminum ions. Concentration will be our 0.023 moles divided by the 0.035 liters. Again, moles divided by liters, and that's came from here. And then we can just divide those two, and we would end up with a concentration of 0.66 molar for our aluminum ion concentration. And that's the answer to part B. Now, where this problem is going to get a little more difficult as we move forward is if we had 2 volumes. After the reaction, those 2 volumes have been mixed together. So we would put our total volume here instead of just from 1. The other is if I have 2 concentrations and 2 volumes, I'm going to have to find a limiting reactant, which we can do. It's not a problem. But also, if this were my excess reactant, I would have leftover aluminum, which might be in the solution, and we would have to consider that if this were some sort of compound, not just solid aluminum. All right, but this is a great place to start and get familiar with that notation of square brackets.